Welcome to the screencast about Slipstream, a research project run by SAP Research in Brisbane and the European Research Centre for Information Systems at the University of Münster. In the first part, we are going to highlight the idea behind this project and illustrate its feasibility in a brief demo scenario. Later on, in the second part, we will introduce the system architecture and present the administration tools. But for the moment, let's imagine a fictitious company called Chip Factory. Chip Factory produces microprocessors and semiconductors, especially for business customers of the automotive, ICT, and computer industry. The market on which Chip Factory operates is characterized by just-in-time production of its customers who try to reduce their warehouse stocks. Orders typically are made in the short run to be able to react to market changes. For our fictitious company, this means that sales orders are very time-critical and that its customers try to safeguard their supply chains by entering service-level agreements, especially for the order fulfillment. In our demo scenario, Chip Factory is faced with several problems which make it difficult to comply with its service-level agreements, resulting in high costs for penalties and a loss of customer satisfaction. In particular, real-time access on decision-relevant information is necessary to be able to react on upcoming issues in time. But due to the dispersion of information across diverse systems, this is hardly possible. In addition, the existing BI solutions do not allow for proactive or even automated intervention into running business processes, especially ongoing orders. And finally, it is not possible to provide managers or customers with timely information on Chip Factory's business. To overcome these problems, Chip Factory plans to introduce a business activity management solution. Business activity management, compared to business activity monitoring, consists of several building blocks going beyond real-time business process monitoring and alerting functionalities. In particular, it comprises the ability to gain insight into action, meaning that its findings can be used directly to control or manipulate running process instances. This allows for an automated decision-making on an operational level. Based on real-time data, business activity management also includes the possibility to perform predictive analysis in time and to trigger intermediate actions based on its predictions. With the Slipstream prototype, we intended to realize such a business activity management solution for the SAP NetWeaver Business Process Management. So why is it called Slipstream? In general, a slipstream is the area behind a moving object. In the context of business process management, this area is represented by the data residing in the wake of the current state of a running business process. The goal for our prototype is to utilize exactly this kind of data in real time for further processing. And the underlying technology which is being used here is complex event processing. So how does complex event processing work in the context of business activity management? The basic element is the event itself. An event is any observable occurrence at some point in time. Within a business process, such an event is typically triggered by the state change of a process object, for example, the start of new process instance, or the completion of a human task. But also other internal sources like ERP or CRM systems, or even external sources like GPS transmitter of delivery trucks, can contribute events which are then being sent via an event channel to the processing unit. This event processor is responsible for performing different kinds of operations on events. It also takes into consideration any contextual data, like for example customer or product databases of a company. The resulting complex events are then being used by diverse event consumers like for example dashboards, notifications, or even the BPM engine itself. Our prototype is built up on this generic architecture by using SAP NetWeaver BPM as BPM engine, the Sybase Aleri streaming platform as the event processing unit, and SAP Business Objects Excelsius as real-time dashboarding solution. Now we are going to have a look at the features that have been implemented so far in our prototype. This prototype allows for visualizing process metrics in real time, based on the events being triggered by the BPM engine. In this example you can see order cycle times of Chip Factory's order process, as well as the number of open and completed orders. An excerpt of the event channel illustrates the flow of XML events necessary for calculating all the metrics. But you cannot only visualize metrics on process level, but also on task level. Here, using the examples of checking the creditworthiness of customers or the availability of ordered products. And finally, even process context data can be accessed in real time for calculating, for example, the total amount of ordered products of the current day. Based on real-time data, the event processor is also able to detect different kinds of patterns. Here you can see a list of critical orders. An order is critical, for example, if it exceeds a certain amount of ordered items. Such an order might require a priority status during order fulfillment. Another more complex example detects if two or more identical orders arrive in a very short time period. This might have happened unintentionally, so that we want to inform the customer or to suspend the duplicate order. Suspending, cancelling or starting process instances is only one possibility to control processes by the event processor. In this example, we are using an event-based choice which is triggered if a duplicate order is detected and which engages a sales agent who then starts a callback. Due to certain limitations, we had to model these aspects explicitly in the demo scenario, but typically, the event processor could just use interfaces of the BPM engine to suspend the affected process instance and to start a separate callback process. Another possibility to control running process instances is to manipulate gateways. Based on the average order cycle time, which is an indicator for the general workload of chip factories' order fulfillment, the shipment mode for orders is changed from a cheap standard shipment to a more expensive express shipment automatically. Hereby, the compliance with service level agreements, for example about delivery delays, can be enhanced. Real-time predictions allow, for example, to observe the expected delivery time of open orders during the overall order fulfillment. Based on these forecasts, the deviation of actual and planned delivery is assessed in time so that further actions can be triggered, like, for example, sending a notification to the customer about possible delays. But also relevant business metrics can be used for predictions. Here, the daily turnover is forecasted based on the current orders and it is compared to a sales target. If the daily target will be missed eventually, the event processor might inform customers about a discount for new orders for this particular day, for example, by sending a Twitter message. Besides Twitter, we also used email and SMS to inform customers or managers about findings that have been made by the event processor in time. But this is just a small excerpt of possible communications channels that can be used automatically. Another advantage of our business activity management solution is that it can also include events from different other sources. Here, we simulate a simple customer claim form, where a customer can enter whether a delivered product is damaged or wrong, or whether the delivered quantity is incorrect. If he submits the form, an event is created and placed on the event channel. This event can then be used by the event processor to calculate more complex metrics, like the perfect order rate, which consists, besides order entry accuracy, warehouse pick accuracy, and delivered on time, of the percentage of orders that have been shipped without damage. The underlying data is typically dispersed across different systems within a company and therefore has to be integrated. Based on the data of the events, it is also possible to provide more detailed information on such aggregated metrics, like for example on the pick accuracy, which is separated by the warehouse units for controllers, storage devices or CPUs. Finally, we are also able to integrate business rules defined in the SAP NetWeaver BPM module. This allows for organizing decision logic at a central place, while enhancing the maintainability of the overall system. Business rules are used, for example, to specify the threshold for marking an order as critical. That was a brief overview on the features that have been implemented in the Slipstream prototype so far. In summary, the Slipstream prototype leverages state-of-the-art complex event processing technology for building up a real-time business activity management solution based on the SAP NetWeaver platform. And it exemplifies the feasibility and benefits of such a solution in a brief demo scenario. Thank you for listening to the screencast about business activity management based on complex event processing, and feel free to contact us. Your questions and comments are welcome.